finishing up, which means a test is the calendar that is on Google Classroom. You can see kind of what the scheduled plan is. So with word problems, you need to first identify if we're looking at an arithmetic or geometric sequence, and then you've got to decide, is it asking for one term in the list, or is it asking for a sum of the terms in the list? So question number 1, Callie's New Year's resolution is to work out each day on her elliptical. The number of calories she burns each day is shown below. So here's our first 4 terms. Write a rule, so we're going to actually write out the explicit formula for the sequence and find the number of calories she will burn on the 30th day, assuming this same pattern continues. So looking at these numbers, are we looking at an arithmetic or a geometric sequence?
Arithmetic.
It is arithmetic because it is adding what? 8. So our common difference is 8. Alright, so let's start out by writing our rule or our explicit formula that goes along with this problem. So it's arithmetic, so this is the formula we're looking at. AN equals D times n minus 1 plus A1. My common difference is 8. When we're just writing a rule, we go ahead and leave in. We don't have anything to plug in right now. And then I have plus 349, my first term. And go ahead and simplify this. So this formula can help me figure out how many calories she's going to burn on a specific day. And whatever day that is, that's what I would plug in for N. The next part is asking me to find out how many calories she's going to burn on the 30th day. So am I finding one specific term, or am I adding the first 30 together? I'm just finding the 30th term, so I do not need to use sigma. Let me get 581. calories. Any questions? No. Alright, number 2. After the first year, Jackson's truck is worth $38,000. If the car depreciates, what does that mean?
Loses value.
Loses value by 10% each year. How much will it be worth after 8 years? So when something is depreciating by a percentage, how do you figure out like what each next year would be? What do you do with that percentage?
Would you just add 10 to the existing 10%?
We do not add 10.
Would you multiply 0.1 times the 38,000?
So if we multiply, that's the key thing. If we multiply 0.1, that's going to tell us what we're losing. It doesn't tell us what the current value is. So
You multiply 0.9?
multiplied by 0.9. So since we're multiplying, that makes it what kind of sequence? Geometric. And we're not thinking about how much is it losing, we're thinking about how much are we keeping, how much value stays, and that's 90%, so 0.9. So my ratio is 0.9 because that is the value that it's keeping. It does not ask us for the rule, so we don't have to write out the general rule. All it says is how much will it be worth after 8 years. So am I only finding the 8th term, or am I adding its value after year 1 to its value after year 2 and keep adding the values? I'm going to add. So if I say my truck is worth, so in year 1 it's going to be $38,000, and then I'm going to add 0.9 times 38,000. So after year 2, my truck is worth $72,000. No, we're not going to add them together. If we added the value of the truck by year 8, it would be worth hundreds of thousands of dollars. That doesn't make sense. We're only finding the 8th term because its value the first year is $38,000. The value the second year is $34,200. I don't need to add those two together. So I'm only finding A8. And it's geometric, so we're using that formula. A1 times my ratio to the 8 minus 1 power. And we get $18,175.28. That makes more sense. That's how much it could be worth. You know, it would be less. If it depreciates, its value should be quite a bit less. So you've really got to think about, okay, if you find a sum, you get some big number. If I found the sum, so that would have been 1 to 8. We would have got $216,000. Right there, you should have been like, that doesn't make sense for my value to be that. So when you get an answer, think about, does it make sense? Number 3, Jamie opened a new savings account with $1,500. The balance for the first 3 months is shown below. So here's our first 3 terms. Write a rule to represent the balance of her account. So we are going to write out the generic formula and estimate the balance after 3 years. So look at your numbers. Am I adding the same thing every time, or am I multiplying by the same thing every time? What do I add to 1,500 to get to 1,545? 45. Do I add that again to get to the next one? No. So it's not going to be arithmetic. So it has to be geometric. See what it's multiplying by. 1.03. Good. That means that's a 3% interest. Don't think that if you open a savings account, that's going to be your interest rate. It might be a 0.03%, which would be like 1.0003. So this is not a realistic question. The rule, so just the AN basic formula, It's going to be A1 times my R of 1.03 to the n minus 1 power. And now we're going to estimate the balance after 3 years. So well, first of all, that says years, right? What am I given? Months. So how many months are in 3 years? 36 months. Each term is a new balance. When you look, at the end of the year in December, if somebody says, how much money do you have? Do you look at just your current balance, or do you go back and pull all of your statements from all of the months and add them all together? You just look at your current one. What you had in January does not matter for how much you have now. You don't get to add all that together. So each month is a new final balance. So we are not finding a sum. We're only finding the 36th term. So we're going to find A36. You get 4,220.79. Question 4. Andrew is trying to save up for a trip to the beach. He gets a piggy bank and deposits the amounts shown below. How much will he put into the bank on the 14th week? And how much will be in the piggy bank after 1 year? So these numbers represent the actual amount of money that he's depositing or putting into the bank. So on the 14th week, that's saying specifically how much is he putting in. That's going to be 1 term. So we're going to find the 14th term. But then it asks how much total is in the piggy bank after 1 year. So the second time we will be using a sum because we want to know how much total is in there. So for the first one, it does not ask us to write out a rule, so we don't have to do that. So for the first one, we're going to find the 14th term. That should be A14. What's my common difference? 0.25. And then 14 minus 1 plus 2. Yeah, this one was arithmetic. Sorry, I skipped that. So on week 14, he's going to put in $5.25. Now, if we're going to find the total after 1 year, How many weeks is that?
52.
52. So we're going to be finding the sum. So we're going to use sigma, n equals 1 to 52. And then over here on the side is where we put our explicit formula. Now, it technically does not have to be simplified. When you're taking the test, it doesn't matter if you simplify it or not. So if I do 0.25, we leave n. When we do sigma, n has to stay. $435.50. Four more. Number 5, an auditorium has 14 seats in the first row, 16 seats in the second row, 18 seats in the third row, and so on. If the last row in the auditorium has 30 seats, how many rows are in the auditorium? This one's tricky. It doesn't say that there are 30 rows, 30 terms. It says that the last row has 30 seats. So this would be row 1, row 2, row 3, row, I don't know. Is this an arithmetic or a geometric sequence? It is arithmetic. So I'm just going to jot down that formula. If I'm finding the number of rows, which variable am I actually trying to find? Any ideas?
N.
It's n. We're trying to find, see, if each row is its term, we want to know which term number gives us 30. So that's n. So we are trying to find n. Now an, that's going to be 30 because we know that my last term is 30. Do we know a common difference? 2. I don't know n, and I know my first term is 14. If I subtract, you might do this a few different ways, but if I subtract 14, I would get 16 equals 2n minus 2. That would be 18 equals 2n. So n equals 9. Okay. So there's 9 rows. And we also want to know how many total seats are in the auditorium. So I have to add up all of the seats in the first row, all of the seats in the second row, and so on. So that's going to be a sum. So that would be the sum from the first row up to how many rows? 9. And then my formula was this. This is a tough one. We get 198 seats. Number 6, an insect population is growing such that the number of insects is 1.2 times larger than the previous generation. Suppose the number of insects in the first generation is 100. So my first term is 100. How would I find my second term? Yep. How would I find my third term? Yep. So those are the first few terms. We want to know, so this is after the first generation, the second, the third. So we want to know how many are there in the 11th generation. Is this an arithmetic or a geometric? It is geometric because we're multiplying by 1.2. Am I finding the 11th term, or am I finding the sum of the first 11 terms? It's actually the 11th term because each term is a new total population. So we want to know the total population on the 11th, which is the 11th term. So these can be kind of confusing. So Generation 1, there are 100 insects. Generation 2, there's 120 insects. Generation 3, there's 144. So Generation 11, that's just the 11th term that we're finding. So we're going to find A11. So it's A1 times my R, 1.2, to the 11 minus 1 power. We get 619.17. The football team is running a jackpot in which the prize will start at $1,000 and will increase by $200 each game until there's a winner. Assuming there are no winners so far, what will the prize be at the 16th game? So the first game, we've got $1,000 in the pot. And then we're going to add 200 to that by the next game. So how much is going to be in the pot? 1,200. And how many is going to be in the pot on the third game? 1,400. So this is the amount each time. This is the amount that's in the pot. The jackpot. Is this arithmetic or geometric?
Arithmetic.
Arith, because it's adding. My difference is 200. So if I want to know the prize on the 16th game, am I finding the 16th term, or am I finding the sum of the first 16 terms? It's just the one that, the first term. This is how much is in the jackpot, game 1. This is how much is it. I don't add 1,200 the next time. I don't add 1,400 to the pot. So this is game 1, game 2, game 3, up until I get to game. So, I told you, this is the hardest part, is figuring out if it's a sum or not. And there's really no set way for me to tell you this is how you know, because they can be worded so differently. You've got to really think about what each term means. So this would be the common difference of 200 times 16 minus 1 plus 1,000. Alright, and then the last one is maybe the easiest one. Find the sum, so it tells you right there we've got to use what? Sigma of the first 60 positive even integers. What are positive even integers?
2, 4, 6.
Yep. 2, 4, 6, 8, and so on. Is this arithmetic or geometric? Arithmetic. What's my common difference? 2. So I'm finding the sum from n equals 1 to what? 60, because I'm finding the sum of the first 60. And then it's my common difference of 2, n minus 1, plus a1, which is 2. And you should get 3,660.